In previous videos, I showed you how to connect torque angle transducer and load cell to MC950 and how to calibrate them. In this video, I'm going to show you how to collect data dynamically using MC950 and transducers. We can go into Acquire Setup, click on Acquire Setup. Again, we have tabs here. In previous video, I showed you the analog input, tabs on how you use it. In here, angle is part of torque angle transducer. So it measures rotation of the shaft or the rotation of the bolt. In here, angle 1 is enabled. The counts per revolution is based on what's on that transducer. In this particular transducer is 2880. What it means, for 360-degree rotation, it will generate counts of 2880, which corresponds to 1/8 of a degree resolution. Direction can be recorded either way, can be bidirectional, clockwise positive, or other directions. Usually, if you leave it at bidirectional clockwise positive, it will record both directions. And if you have a left-hand bolt, you can go maybe bidirectional counterclockwise positive. And also, if you tighten by hand and you don't want to see going back and forth of the signal, you can go unidirectional clockwise positive or unidirectional counterclockwise positive. But most of the testing, we use bidirectional clockwise positive. RPM smoothing here is 20. What does it mean? It means every 20 degrees of angle that torque advances, torque angle trans advances, it will summarize it and it would generate an average value and divide by time. That creates a RPM. So it's rounds per minute. It's driven from degrees of rotation and time. As you see, when they are enabled, the star goes next to the channel. Here again, we have enabled channel 1 and channel 2, which is channel 1 is low, is a torque angle transducer, channel 2 is low. In the previous video, we saw that. In this video, angle 1 is enabled. Next screen is diagnostic. It's a little program here. We can show you all the channels. If you click on run, it will just show you all the channels that are attached to this system. The system that I have is an 8-channel system, and it shows you the analog signals. And if you do a little rotation on the angle, we see some movement here, which is it shows in counts, not degrees. And all these values are in the raw analog values, and there is no unit attached to these. It's just a quick thing, something that is working or not. Stop this. Next tab is file name, and here shows you how to name the file that you want to save to. For instance, it defaults to test. I can say my test, and it starts from sample number 1. It advances all the way to 999. Each rundown, each bolt tightening is one rundown, one file. You can change the location of where it goes and file name. Save method defaults to auto save, means after done of the data collection, it automatically saves it under this name and this extension. You can also select manual, means manually you have to give a name for each time you do a rundown, or you can do automatically saves and advances to next file. This is rarely used unless you're familiar with the system and you have a set of bolts that you're going to test one after another one. In this section is the zero analog input before R. It means it would zero out all the analog signals if it is less than 3% of full scale. Sometimes you don't need this, sometimes you do. Sometimes when you don't need this, when you have a tension there, measuring the tension, if you have a low level tension, it will zero it out for you. And if you were working with a very low tension or load signals, it will zero out for you, or low torques. So it's sometimes it's better just take it off and just not zero it. As for comments after acquire, if you click this on, a window would pop up and ask for your comments. Then you have to give an answer, and that they would save with the file itself. Next one is recording. Uh, Recording base is time or angle. What it means, it will record all the channels, but based on some time here. In here, based on angle movement. But majority of the work we do is time-based because there's load or tension involved in there. So we need time because there's no movement on angle when there's a load on that bolt. So leave it on time and recording speed. That's how fast we record 1,000 samples per second. If that generates that much data for each second, if you want to have less data, you can reduce this. If you have more data, you can increase it. Time-based recording, that's how long the total time recording will happen. In here, we give 10 seconds. It starts and stops in 10 seconds. A trigger value means when do you start and when do you start the recording. It can be done based on trigger slope and trigger on and trigger value. Slope is the, if you can use the positive or negative slope of the signal, means, or absolute, either way, means plus or minus slope of the signal. Trigger on which channel, here we designate as channel 1, it can be channel 2, then it changes to load. If you leave it in channel 1, it changes the label torque 1. And torque value is defaults to 10 Newton meter. You can change it, and depends on how much signal you have. You can change this value. That's when the recording will stop. Once it reaches 10 Newton meter, it will take off and will record. What happens? The values before 10 Newton meter. You can also capture that by using a pre-trigger value. Pre-trigger value means signals reaching before 10 Newton meter. In here, 10%. What it means, 10 seconds that we have for total recording, 10% of that 10 seconds, which is 1 second, is allowed for the signals before reaching 10 Newton meter. So you could have signals before reaching them. The reason for doing this is if you're setting up your recording and you don't want to prematurely trigger your data collection, you can set higher value and do all your work, then start taking data. Once you start taking the data, when it reaches 10 Newton, it will take off and record all the values. But not in order not to lose that data before 10, use the pre-trigger value. So you can change this and you can see the effect of it on the screen. So we are set for calibration, and we are set for the recording time and file names. Now I'm going to show you how to collect data, a short data collection. Okay, we are back into MC911 main window. In this window, you can see the graph area. This is a graph here. A single graph can be double graph or quad graph. Means 4 graphs. All of these graphs are programmable. Program each of them. You can place the cursor on the black area and right click. There's a pop-up window, select graph setup. In this graph setup, quickly I'm going to explain to you what you're going to see, but later I'll come back and explain you more. So in here we're going to use real time. By real time means that you will record the graphic data as a real time. Jump to the axis, you can go into the and show to what you're going to see. In here, our X can be angle, and Y1 can be channel 1, which is torque, and Y2 can be channel 2, which is load. So we are going to see X as an angle, Y1 as a torque, and Y2 as a load. So Y1 and Y2 and X. So we are ready to go here. Make sure real time. Okay, this is a short version of it. So once I select real time, this square becomes yellow. That designates as real time. And once we have a real time graph on the screen, these two buttons become enabled. So in here, if I just click on scope, what I will see is just torque angle value. It's kind of hard to see here because there is no movement here. But to have a better region, I'm going to stop it and change this to time. Go back, graph setup. Here, instead of angle, I will use time so I can see some running. If I click on scope again, you see a real-time running data and going back and forth. So I can stop it. If I want to record it, I can click on ARM. It will record the data. Scope will only show the data. So set to record and save it, click on ARM. So this window pops up. This shows the ARM window. So what it tells you is the ARM will trigger at 10 Newton meter. That's torque. Then it will start all the way to 10 seconds and record data and stop. You can trigger it manually, or you can ask to trigger it automatically based on this Newton meter. So I'm going to put some torque in this setup. As you see, I just put some torque on it. So we're done. We have time, x-axis, torque, and load, which displays, if I put the cursor here, displays torque, load, and time. You can change the time to angle if you want. Now we're seeing as a torque, load, and angle. So this is a short video of that I showed you how to collect data. Next videos I'll explain you more about the data collection.